Our learning objective here is that we want to work on a special case of the hypothesis test for B1, like beta 1. So when we are talking about the simple linear regression, we said that the equation that we are going to have for the simple linear regression is going to be, we're going to write down here. So we said y is equal to beta null estimate plus beta 1 estimate x plus e, and this is my regression model, right? So from here to here is going to be my regression model, which gives me the value of the predicted amount. So in the previous video, we worked on the hypothesis test, like general form of the hypothesis test on these two parameters. In this video, we want to learn about the situation that we want to make sure that this beta 1 is not equal to the 0. So the parameter of interest is still beta 1, but we want to make sure that it's not equal to 0. The approach that we are going to use, we call it analysis of variance approach, or ANOVA table. So this ANOVA approach, it means that analysis of variance, right? So let's work on the steps that we have. The first thing is that, okay, what's the parameter of interest? The parameter of interest is beta 1, right? And then it says that null hypothesis. So for the null hypothesis, you would say our beta 1 is equal to the 0, because it's a special case. Think about it. If beta 1 is equal to 0, what's going to happen? Think about it for a moment. So it's like that. This is 0. So we can't find the relation between y and x. In fact, we would say that we can't say that the relation between y and x, it's linear. So we would say beta 1 is equal to 0. The alternative hypothesis is beta 1 is not equal to 0, right? So we have the alpha is same as before. So we consider, like, for example, alpha is equal to 5%. In fact, we would say failure to reject this H null, that is beta 1 equal to 0. So failure to reject this H null is equivalent to conclude that there is no linear relationship between x and y, right? For any alpha that we would have. So we have all of these. Let's go and talk about the test statistic. Test statistic here is the result of the ANOVA table. So I'm gonna write down here. First of all, we work with the F table. So our test statistic is going to be F null. And we would say that our test statistic is the sum of the square of the regression divided by 1. This one is important that we keep it here, because this is the simple linear regression. Degree of freedom of the regression line is going to be 1. We just have one x, right? So it's going to be 1. Because of that, we are going to have the SSR divided by 1. But if it was multiple linear regression, in that case, for example, you had x1, x2, x3, so this number would change. So because of that, let's keep it here. Sum of the square of the regression divided by 1. And then in the denominator, we are going to have sum of the square of the error divided by degree of freedom of the error. When you look at this one, you can say that, okay, so the degree of, you have beta null and beta 1, right? So you have two parameters that you are interested in, generally, that you found out. So you can say the degree of freedom of the error is going to be n, the total number of the sample, minus 2. So this one, SSR over 1, we call it mean squares of the regression. So another name of this is the mean squares of regression. We show it by MSR as well. Another name for this one here is the mean square of the error. So we show it by the MSE as well. So as I said, this one, this F null, is a result of the ANOVA table, analysis of variance table. Next one is the rejection region. For the rejection region, we say that we are going to reject the null hypothesis if our F null, the F that I found out here, okay, it's going to be greater than some F from the table. So like the T table, chi-square table, Z table, all of these ones that we had and worked with, we read it from the table. F table is very similar. The only difference is that here you would work with the two different degree of freedoms. So for this one, it's going to be F at alpha, and then you would have the degree of freedom of your regression, right? Which is 1 here, and degree of freedom of your sum of a square of error, like your error or residual, which is n minus 2. So if we quickly look at the book, this is the reference book, right, for us. And at the end of the book, when we are looking at the F table, values of T, so this is the T table. So if you remember, for the T table, we had T based on 1 degree of freedom, right? 1 type of degree of freedom. But for F, it's going to be based on like 2 types of the degree of freedom. So when we are looking at the F table, so I'm going to make it closer, but you have it in your notes as well. So with the F table, the only thing that we need to be careful is that each of these F tables are for different alpha. For example, this F table is for the time that alpha is equal to 5%. So this F table is for the alpha that for the time that alpha is equal to 0.025%. So be careful when you want to read from these tables. The first thing that you're going to check after you find out your F tables is that you're going to, on top, on the first line, you're going to read it to see that if it's for what's the value of alpha. And then it's very easy. It's like that. Okay, so on the first column that you see here, I'm going to have the degree of freedom of my denominator, which is n minus 2, right, here. And on the first row, I'm going to have the degree of freedom of my numerator, which is 1 here, right here, numerator. So for example, here is 1, and then n minus 1, I'm going to find it out. So here, you would say the first line, the first row is going to be degree of freedom of your regression line, and the first column is going to be the degree of freedom of the error, like the residual. Okay, so this is the value that we are going to find out from the table. So after we find out the value from the F, so we are going to say that we are going to compare this with this, like the same things that we had before for the other hypothesis test. And then we are going to have our like computation, put all of these numbers. So with the computation part is the part that you're going to make your ANOVA table. Make ANOVA. And ANOVA, as I said, is the analysis of, this is of, and then variance. And then you're going to make your conclusion. If your F null was greater than the F from the table, then you're going to reject your null hypothesis. If your F null was less than F of the table, then you fail to reject the null hypothesis. Most of the time, the F null, if it's really big, like if it's like 150, we would say, okay, so the F null from the sample definitely is going to be bigger than anything that we find from the table. So we would say, okay, so we reject the null hypothesis. We are looking to reject the null hypothesis here, right? To say that, because if we can reject the null hypothesis, in that case, we can say that, okay, so this x is not equal to 0 probably, and we can have a linear relation between the y and x. Okay, so now let's talk about the ANOVA table. As we said that the ANOVA, for the calculation, when we want to find out F null, we need to do the ANOVA table. ANOVA table has a general rule. So, and like for example, this one is the simple one, simple linear regression. For the multiple linear regression, whenever you want to use the ANOVA table, you are going to go with this method. You are going to have 5 columns. The first column is the source of the variation. So I'm going to just draw a line here. So this is the variance. Okay. My line is okay. So with this one, here we want to work on the ANOVA table. So I would write down ANOVA table. We want to construct our ANOVA table. The first, I said that it has 5 columns. The first one was the source of the variation. Source of variation. What does it mean? It means that, for example, your regression, all of the regressors that they are source of the variation. Or your error, that's the source of the variation. So I would say that it can be my regression, or it can be my error, and then I have the total source of variation as well. So that's the first column. Next column is the sum of squares. So we have another video as the sum of squares regression analysis. You can look at it quickly. But here I'm going to write down sum of squares. So for regression, sum of a square of regression, we're going to write down the value for it. And then here is going to be sum of a square of error. And here is going to be sum of a square of the total. Sum of a square of the regression, we said that is going to be like beta 1, right? So we have it in the equation, in the other video equations that we wrote down in the other video. But just to quickly write it down here, this one is going to be equal to the beta 1 estimate, right? And then you would times it by the s of the, I think it's the s of the xy, yeah. Yes. So this is the sum of a square of the regression. The next one is the sum of a square of the error. For the sum of a square of the regression, we would say the sum of a square of the error, we would say it's equal to the sum of a square of the total minus this amount. So this one is going to be equal to sum of a square of total minus sum of a square of the regression. And sum of a square of regression, we found it here, right? So you can put this value here. For sum of a square of the total, we had it before, it's going to be sum of a square of the y. So here is going to be sum of a square of the y. Or you can write down as like, if you write down SYY, it's going to be the same. Or you can write down SYY. So this is my second column, which I found out the sum of a square of the regression and the sum of a square of the error. The next column is going to be degree of freedom. So I'm going to write down here as degree of freedom. For SSR, when we are talking about the simple linear regression, the degree of freedom is going to be 1. For error, it's going to be n minus 2, right? And the total degree of freedom is going to be n minus 1. So I have my degree of freedom here. The next column that I'm going to have is going to be mean square. So I'm going to write down here mean squares. So for the mean squares, I have the mean square of the regression and I have the mean square of the error. So what are you going to do? For the mean square of regression, you would say it's SSR divided by the degree of freedom of the regression. So it's like that. You would say this one divided by this one is going to give you this. So it's going to be SSR divided by 1. And for this one, MSE, the same things. You are going to say SSE, whatever it is, divided by this degree of freedom, n minus 2. So we find out the MSR and MSE. The last one is the time that we say ta-da, because we are going to find out the F null, like the same F null that we were looking for, right? Then we want to calculate that, so it's going to be F null. So an F null is going to be this one divided by this one. So MSR divided by MSE. Okay, so and then we did the calculation, we go to the conclusion, which is we are going to reject the null hypothesis or failing to reject the null hypothesis. So let's quickly review that. When we want to find out the beta 1 for the test the hypothesis for the beta 1 and equal to 0, beta 1 estimate, we would need to use the F table and ANOVA table, or analysis of variance table. ANOVA table has 5 columns. The first one is the source of the variation, then sum of the squares, degree of freedom, mean squares, and F null. F null is the result, is the one that we are looking for. We need to make sure that our F null from this ANOVA table, which comes from the sample, is greater than the amount of the F that we read from the table of the book. In that case, we can say that we reject the null hypothesis, which was like this one is equal to 0, right? Okay. Source of variation is going to be regression error, and we have the total as well. So we are going to write down the sum of a square for this source of variation, whatever it is, and then the degree of freedom that we have. The sum of a square divided by the degree of freedom, this one divided by this one, is going to give you the mean square. The sum of a square of the error divided by degree of freedom of the error is going to give you the mean square error for this column. And the last column is that you're going to divide the mean square regression by the mean square error to find out the F null. So that's the basic logic of the ANOVA table. When you learn this one, if we learn this one, properly, if we get the concept of it, then the multiple linear regression is going to be a piece of cake for us, right? So I'm gonna, after this, we're gonna work more on these ones. But this is the whole lecture about the ANOVA table and the special case of the hypothesis test when we have the beta null equal to beta 1 equal to 0. We don't want the beta 1 to be equal to 0.